SwayamPrabha. Digital India. Educated India.
Hello everyone, welcome to the course on computer aided drug design. We will continue on the topic of QSAR. The previous class we talked about what are the important statistics we need to obtain in order to say the regression is good and it has got good predictive capability. R square adjusted should be at least greater than 0.6, Q square, that is the cross validated R square or leave one out method R square, like that. R square predicted they should be greater than 0.5. Then R square minus R naught square, that means when you force it to pass the regression line through the origin, we call that R naught square divided by R square should be less than 0.1, okay. And then when you force it to pass through the origin, the slope should be, okay, almost 1, that is in this region. And then we do the other way, instead of y is equal to, we do x is equal to, okay. Then we use again r dash naught square, make it pass through the origin, and the corresponding slope is given by k dash, that also should be around 1. So we need, it is quite stringent, we need to have lot of conditions to be satisfied before we say that the regression model is good, okay. It is very important that you have a validation, that is the test set, because you may fit 3 points like this, but in reality the data may be going like this, okay. So there could be going up or going down, so it is very important that we fit actually. Your R square adjusted, R square predicted or cross validated for the training set may be very high, but when you do for the validation, the whole thing could be in a big surprise. So you need to always have a validation or a test set. Okay, there is something called leverage. Okay, imagine that this is your descriptor x and this is your activity y. You are trying to get a few data points and you are plotting between the x and the y, and for most of the compounds the x, that means the descriptor value is almost the same except for one compound which is far away, okay. This type of fitting is not very good because your entire slope will depend upon this particular point, okay. This is called a leverage of 1, which is not very good. That means you have all the data points, the descriptor value is almost same and only one has something different. So never have a QSAR like this. You should have at least 1 or 2 points here and here like this, you know. That means the descriptor values for the compound should be sort of distributed along rather than all of them clustered at one place and only one of them far away, because that could be leveraging your entire slope, and the errors in this particular point could completely affect your QSAR. So always select a descriptor which is distributed in certain range, okay, if you are trying to develop a QSAR. That is another important point actually, okay. That is another important point in addition to other points which we talked about in selecting descriptors. Okay, so how to get a better fit? You can have a higher order model, quadratic terms in the model, drop superfluous terms, use transforms. For example, what do we do? Suppose we measure the concentration at which 50% of the cells die if you are doing an anti-cancer activity. If you are doing antibacterial concentration at which 50% or 90% of the bacteria die, we do not use that. Log of 1 divided by C50 is PIC50, okay. This is called a transformation, because what happens is these concentrations could be in micromole or millimole, so 10 power minus 4, 10 power minus 3, all those terms come in, but when you take logarithm and put a minus in front of that, they will be all positive numbers, so the regression will be better. Okay. So never use your dependent variable in the order of 10 power minus 4, 10 power minus 3 and so on, but try to take logarithm so that they will be in whole number. Okay. Then another important point, factors range too narrow, like suppose you take a set of compounds and the descriptor values are almost the same, and then when you try to fit, you may realize, you may feel that there is no difference, the activity does not change with the descriptor, but in reality it may be changing like this, but because your range is so small that they all may appear as if there is no effect on the activity. Okay. So it may be going like this, but range. So when you select descriptors, you need to say whether they are covering a reasonably good range or they are narrow, all clustered together, because that may give leverage, that may give this type of errors actually. Okay. Of course, when we are talking about synthetic chemistry, it may be difficult to synthesize so that a particular descriptor changes in over a wide range. For example, I want to change log P, I may think of putting OCH3, CH3, fluorine, chlorine, so that log P changes. So that is not bad, but then it may be difficult to synthesize those type of derivatives, that may be a problem. Another point is when you are changing log P, it may affect electronic or steric factors, we saw in the previous classes. So it may be not completely possible to just change one particular property without affecting other properties. So these are some challenges when you do QSAR. Overfitting. Okay. So the data points is like this, so a simple model you are fitting, but then you can have very complex model, try to fit each and every point, that is called an overfitting. You do not need to have that. Okay. It is good enough to have like this. This is called a overfitting problem. So when you try to fit simple model with training error but giving good prediction, complex model very complex, is going up and down trying to fit each and every data point, but it may give a very poor prediction. A model perfectly predict training data may be not good or even useless for prediction. Okay. So you have to be very careful about overfitting problem. There are many problems, there is something called Occam's razor. If you have two equally likely solutions to a problem, pick the simplest. Okay. So always pick the simplest, do not go for very complicated. If you get almost the same answers with two different we say a linear model and a quadratic model, you get R square and R square adjusted Q square almost the same, little difference, always go for the linear model, you do not have to go for a quadratic model. If you have a two descriptor model and a single descriptor model, there is only small change in the Q square or the validation R square, go for the one descriptor model. That is what this Occam's razor tells you. If you have two equally likely solutions to a problem, pick the simplest. Okay. Likely they are very small difference, but if you see big difference, yes, you may go for a complex model, but if it is a small difference, do not do that. Look at this, for a very simple two class binary classification problem. Okay, you have some data, you want to separate these data into two different groups. Okay, you can draw the line like this, so this becomes one group, and this becomes, or you can draw the line like this, then these groups change. So this could be low active compound, this could be high active compound. So where do you draw the line, how do you differentiate, okay, between the low and the high active? You could have one QSAR for low active compound and one QSAR for high active compound. So depending upon how do you classify, some of the data points may go here or some of the data points may be going into the other group. So that is a problem. Let us look at this particular software, Build QSAR. It is a spreadsheet type. The user can enter the data set composed by the structured definition of the compounds. So it is very quite good. We will look at it. That is called a Build QSAR. yeah, this is the software built QSAR, and okay. Okay, so as you can see, this is your activity Y, and here it is giving 5 descriptors. We can keep increasing the descriptors also, no problem. Say you can add, okay, compounds, or you can add variables, add items, okay. So you can remove items, compounds, all those things we can do. So we can give some title for this. For compounds, then we can have many descriptor data results here, and then try to develop a regression relationship. So as I said, if you have only 5 data points, you can have only one descriptor model. If you have 10 data points, maybe you can think of 2 descriptor model. So if you have some data, for example, let us look at some data. Let us look at an example. These are called anti-inflammatory compounds. These are anti-inflammatory drugs. They are also called cyclooxygenase, selective cyclooxygenase drugs. Cyclooxygenase comes in the arachidonic pathway of the inflammation. I think I talked about it long time back, okay. And these are marketed by companies like Pfizer, Merck and so on, Bextra, Vioxx, Celebrex, Dupe. These are all very selective, whereas nimesulide is not a selective drug. It goes and binds to cyclooxygenase 2, cyclooxygenase 1 and many other enzymes in the pathway. The activities, I know I took it up from the literature, okay. So now I have these compounds. I want to develop a QSAR, so I can get the descriptors for each one of these compounds, okay. And then I can get the descriptors for each one of these compounds using eDragon, okay. And then I can look at which descriptors have good correlation, highest correlation with this, and then select those descriptors and put it in the build QSAR, and then try to develop a QSAR model, okay. So we can use first we can use if you remember zinc database, nimesulide, okay, sorry, nimesulide, nimesulide. Okay, this is nimesulide. I can okay, then I can download. I can download the SDF file here, okay. I can download the SDF file which I already have it, okay. So nimesulide SDF file is there, okay. Then if you want to convert into SDF also, this open Babel is there. Please remember, if hydrogens are not there, you must add hydrogen, make explicit, because zinc might not put hydrogens, as you can see here explicitly. So you can use open Babel and convert that SDF file, for example, yeah. Slide open, okay. Yeah, hydrogen is already there, but if you do not have hydrogen, then we can add a hydrogen and then create another file, okay. Once you do that, we have the SDF file, and as I mentioned, eDragon needs okay, eDragon requires SDF file, okay. eDragon requires SDF file, so we can load nimesulide. Okay, so here we upload data, then we upload the nimesulide HDF file. Okay, browse, then we upload CAD QSAR, and we upload nimesulide. Where is nimesulide? Yeah, nimesulide gets uploaded, and then we run eDragon, get all the results like I showed you in the previous class. Okay, successfully loaded. Now I say submit your task here. Okay, and then you get all the results. Okay, lot of descriptors, and you can do the same thing for DUP 697, valedic oxide, rhofic oxide, silicoxib. Okay, and then create an Excel file with all the descriptors. Okay, so with all the descriptors, as you can see here, I created a file DUP 697, valedic, helicopter, rhofic, nimesulide, and these are the activities. Nimesulide has the lowest activity here. Okay, so which I have put in here. Okay, PIC 50 I have put, and these are the descriptors, so many descriptors, and then I tried to find out the correlation between activity. As you can see, correlation between activity and the descriptor. So I have you can see molecular weight it's got a correlation coefficient of 0.86, and ASP another descriptor. So as I said, the eDragon can calculate almost 2000 descriptors. Okay, so so molecular weight I have taken here. These are the 5 molecular weights for these 5 compounds. Okay, then I looked at some other descriptors here. Yeah, this is another descriptor called PIPC05. If you want to know more details about it, you need to look into eDragon to know what these descriptors are. Okay, this is the 5 values for these 5 compounds, like that, you know. Then I have another one. So I picked up some of them which has got very good correlation, 0.988, BHV V3, that's another descriptor, like that, you know. Go down and down and down and down, then A log P log S minus, okay, and then A log PS log P 4.95. So I took these, and then I went to the here, and then I selected 5 descriptor set, and then I put the activities of these 5 compounds. Okay, let me see whether its file is there which I had kept. Yeah, so IC50 I have it here. Okay, so I took 3, 4, 5, 6, 7 descriptors, right. So this is molecular weight of these DUP69 valedic nimesulide. This is the IC50. Then these are descriptors. I selected the descriptors based on the correlation coefficient, which had reasonably good correlation. Of course, you can select more if you have more. Of course, here I will be able to create only one descriptor model because I have only 5 data points. Remember that. So what do? We can say QSAR, we can say variable selection, systematic search. Here there is no 2 variable problem, so we will say plot variables. Okay, so you can see PIC50 versus RDF 025. This is R is equal to 0.98. Then I can say okay, this is with respect to H4P, another descriptor. Again it gives you R is equal to 0.95. This is molecular weight. Okay, it's not very good, 0.863 chalega. Then this is A log PS log P 0.86. Okay, so we can have a AMR, another descriptor is quite good, 0.975. Okay, good. We can look at them. Then we can do tools, options. Okay, then we start doing a QSAR biological activity, so we can do RDF. So we see this is the mathematical regression relation. PIC 50 is equal to this RDF, this gives you the plus or minus 95% confidence minus this, so y equal to mx plus c type. Okay. In fact, it is trying to create a model with 3 parameters. Okay, and so you have degrees of, you have 4 parameters, 5 data points, so degrees of freedom is only 1. It's not very good model. Okay, so as you can see, this is a QSAR. It gives you R is equal to 1. So obviously degrees of freedom is very poor. Okay. So we can take 2 descriptors at a time, maybe. So obviously now it's better because we have 1, 2, 3. Okay, 2, 3. So degrees of freedom is 2. You can see Q square is 0.5 here. F value, these are statistics which you need to understand if you attend a course of mine called Biostatistics and Design of Experiments. You will come to know many of these things. You can look at correlation matrix. We can look at is there a correlation between these descriptors. Okay. As I said, the descriptors should not be cross correlated, which is bad then. Okay. See, some of the descriptors are quite highly correlated. Okay. So if you are developing a 2 parameter model, you should not select those descriptors which are correlated amongst themselves. They are cross correlated, which is not good. Okay, remember that. Okay. So we can have again, if you take each descriptor one at a time, it gives you what is the Q square, what is the R square. So we can select that one which looks good. This AMR looks like a good model. Okay. So you get a good Q square here and you get a good R square. So this 1 parameter model with AMR is good. So you need to do little bit of changes, modifications, okay, before you arrive at the best model. So we can add columns, that means we can add some more descriptors, we can add some more data points. So many things we can do. We can even scale data. For example, if you think you need to take logarithm or you need to take square or square root, then we can do that sort of things also. So this software is extremely user friendly. It works like an Excel, so it's very good. So what is the step-by-step procedure? So you can download your structure from Zinc, check whether hydrogens are also there, otherwise you can use OpenBabel and add hydrogen, and then you can use a eDragon, upload the SDF file and then get all the descriptors. You can go to Excel, and then if you know the activity, you can see which descriptors have good high correlation with activity. You can select those which have more than 0.9 or 0.95, select only them, and then copy them into the build QSAR model. Like this, the activity is coming here and the descriptor value is coming here. Here I have shown only 5, you may have more, and then start doing the QSAR with the different descriptors and see, check out your Q square value and then see whether they are cross correlated. Then look at one descriptor model. If you have more data points, you can look at 2 descriptor model, and so on. So you can do lot of things. This is a good software. I like it because it's very user friendly. We can because this looks like an Excel, we can copy paste from Excel whatever you have what from eDragon. Okay, now what about electronic descriptors? So if you want electronic descriptors, what do we do? Of course we need to do manually. As you know, MOPAC can do electronic descriptors, right, calculations. So okay, let's take a nimesulide SDF. So we need to get the MOPAC file. Nimesulide SDF here is there. Nimesulide SDF is called a MOPAC file. So go into MOPAC. Yeah, you have MOP, yeah, MOPAC Cartesian coordinate. Okay, output file. So we need to go say so I am going to put it here. I will say Nemo. Nimesulide save. Okay, so I am going to save it here. So this will be the MOPAC file for nimesulide here. Okay, you can see from here. Okay, now we will copy that. We'll say convert. So recent places, MOPAC. Yeah, so MOPAC is there. Okay, this is the nimesulide. Okay, now we need to put in the BPM, say 5 or something. Then we will say file save. So we need this one. We don't need this one. Okay, so we need to put it into this. Nimesulide MOPAC. Yeah. Okay, done. Nimesulide out has come here. Okay, so nimesulide out is here. Yeah, this is nimesulide. PM7 calculations have been done. Final heat of formation kilocals, or it's given in kilojoules. Total energy is available, electronic energy is there, core cold repulsion is there. Ionization potential is there. So these are electronic descriptors which you will not get from eDragon. So you can use MOPAC to collect. So for each of these 5 molecules anti-inflammatory drugs, we can collect it running MOPAC, and then again take them to the QSAR software which I showed you, and then see whether any electronic descriptors have a good correlate activity. Okay, so and I also showed you another software. If you want to look at the MOPAC output, that's called the JMOL. So, nimesulide out we can put it inside and you will get the details about structures of nimesulide. So, this is nimesulide. So, JMOL is a good software for viewing structures from MOPAC. Okay, so we can get a lot of details about the structural features, we can develop surfaces, okay, van der Waals surface, solvent accessible surface using JMOL. Okay. Okay, let us go back. So, this is how we can do. There is another software which is called the OChem. This also is quite good. I would like to briefly show it to you. This also can look at descriptor calculations. Yeah. So, this software also can give you the so it has got databases, properties. So, we can get properties, login as guest. So, a lot of properties are there. Okay. Properties you can see melting point, log, P for a lot of compounds has been stored here. Okay, suppose we want to know see it has got log P values for large number of compounds. Log P, solubility, so many things. Okay, now if I want to calculate for a particular okay, model calculate descriptors, yeah. So, I can draw the model, I can I can upload compound from SDF, choose file. So, I can say aspirin SDF, open. So, it takes aspirin SDF, okay. Then we can do calculate aspirin SDF. Okay, so it's a lot of descriptors it can do. As you can see, log P, so many descriptors are there, hundreds and hundreds of descriptors. Okay, it can even give tox alerts and so on. Actually, so many descriptors it can do. So it's calculating these descriptors. So I can click on many items. Okay, so it's calculating descriptors. So this is also a good software for doing this type of job actually. Okay, yeah. So total molecules correctly calculated. You can see descriptors. Proceed to the descriptor download page. So descriptors value. So QSAR, as you can see, has a lot of advantages. Similarly, one can work on QSAR development for angiotensin, ACE inhibitors or beta blockers. So all you need is we need to have some data on the activity from literature for some of these drugs, commercial drugs, and then we go about and start developing okay, so it's given a lot of results. Okay, so many descriptors given. Okay, so many descriptors. As you can see, this talks about alerts, whether there are any alerts on toxicity, and so on actually. Okay. So, that is also a very good software. The OChem can do descriptor calculations. In fact, it also has a model building option. It's also got a model building option. Because of want of time we will not go, but we can upload a linear model. So, I suggest you people have a look at these things also. Okay, so QSAR has advantages and disadvantages. What are the advantages? We can understand the effect of structure on activity. When I put in a particular electron withdrawing or electron donating, what is the activity? We can think of synthesizing novel analogues. We can try to understand interaction between functional groups. Suppose I have one OH in the para position, I want to put another OH. What will be the interaction, or I want to put OSCH3, what will be the interaction, that sort of thing. Disadvantages, of course, false correlation sometimes may arise because of heavy reliance placed on biological data. Too many descriptors and selection of the correct ones, this is very important point which I did talk about, right. Too many descriptors, how do I select the ones which you think is the correct one? I may be missing out the correct one. Lack of experimental design. So, using computational, I will say I want to synthesize a molecule with the chloro in this position, that position. Maybe it is not possible for the synthetic chemist to design. So, or synthesize, they will be able to synthesize only one set of molecules. Okay, so that is a problem. Various physicochemical parameters are known to be cross correlated. Like I showed you, molecular weight, size, electronic features, all of them may be cross correlated. So, not all descriptors will be independent of each other. Okay. So, we will continue more on this QSAR in the next class as well. We will talk about 3D QSAR in the next class. Thank you very much for your time.